Alright, today we're going to move into the fourth method for solving quadratic equations, and that is by completing the square. But before we jump into this, we need to be reminded about perfect square trinomials and what we can do with them, because this is going to come in handy for us when it comes to solving quadratic equations by completing the square. So here we have two equations. We want to solve these equations below by factoring and using the square root property. Alright, so we have been discussing for the last several days, and we just took a test over it, of how to solve quadratic equations by square roots. So that's what we're going to do here. But before we do that, we need to recognize that this quadratic is what we call a perfect square trinomial. So if it's a perfect square trinomial, we can factor it like this. Hold on just a second. Alright, so we need to see and notice that x squared plus 14x plus 49 is a perfect square trinomial, which means that we can write it in factored form as the square of a binomial. So x plus 7 squared is what this breaks down to. And I know this works because half of 14 is 7, and 7 squared is 49. So, now, will you always notice that this is, be able to notice when it's a perfect square trinomial? No. Probably not, okay? That's really not the issue. The issue is, if I were to get it to this point, and I knew that it was a perfect square trinomial, then what am I going to do with it from here? Well, it's very simple. You're just going to take the square root of both sides. This is going to give you x plus 7 equals plus minus 2. Now, when you get it to this point, to this step here, we're going to just continue to solve. Subtract 7 from each side. Now, x is equal to negative 7 plus or minus 2. I don't want to leave it like this, because this can be simplified. Now, if there was like a square root of 3 attached to this 2, you couldn't do anything. But there's not. So what is negative 7 plus 2? Negative 5. And what is negative 7 minus 2? So those are your two solutions. And we determine those solutions by just treating the 2 as if it was positive the first time and negative the second time, and we're done. Alright? We would do the same thing in this problem. So here we have a perfect square trinomial. It's x minus 3 squared equals 20. So again, take the square root of both sides. So x minus 3 equals plus minus. Now, the root of 20, we can break that 20 into 4 times 5. So it's going to be 2 root 5. So we add 3 to both sides. So x equals 3 plus minus 2 root 5. Now, can this be simplified? No, it can't. I mean, you could write it out as 3 plus 2 root 5, and then again as 3 minus 2 root 5, but there's no point in doing that. I don't mind if you just leave it just like this. If it can't be simplified any further, just leave it like this. 3 plus minus 2 root 5. Okay, now, what we just did is one of the skills necessary to be able to solve a quadratic equation by completing the square. This is like the final steps of solving by completing the square. The initial steps involve actually completing the square. So, to complete the square, what we're going to do is follow these steps. It is possible to take any quadratic equation, create a perfect square trinomial, and solve it in a similar way. This method is called completing the square. So, the first thing we want to do, and we do this when we convert from from standard form into vertex form, we isolate the x's. So in other words, we want to get the x's on the left side and everything else on the right side. So ax squared plus bx equals c is how we're going to set this thing up. So if there is a number in front of x squared, like a 2 or 3 or something like that, we're going to divide both sides of the equation by a, so it becomes x squared plus b, and it really should be like this, b over a equals c over a. That's only if, guys, there is an A. Okay? That's only if there's an A, if there's a number in front of the x squared. And we did that when we had to complete the square earlier. Sometimes there was a 2 in front, and we had to factor that out. Y'all remember doing that? That's basically what I'm saying right here. All right, so in number 3, complete the square by taking half of b, square it, and add it to both sides of the equation. So we know how to do that. So I'm going to focus on steps 1, 2, and 3 right now, and then we'll move on to 4, 5, and 6, because 4, 5, and 6 goes with this stuff up here. All right? Okay, so we want to get the x squared minus 18x by itself, and then move that 56 to the other side. So to move it to the other side, we would subtract it. Now, I don't think you necessarily need to show this step. Just move it over and change the sign. So x squared minus 18x, leave a little space, equals negative 56 with a little space. There's plenty of space. All right, now we complete the square. So how do we complete the square? We take half of negative 18, which is negative 9, and square that. So 9 squared is, and negative 9 squared is also 81. So we're going to add 81 to both sides. Now, we added 81 to the left side, so we have to add 81 to the right side. And you're probably thinking, but wait a second, what about when we added and then we subtracted? Y'all remember that? That's when we were only working on one side of the equation. If we're only working on one side, we add and then subtract what we just added, but we're subtracting it outside of the parentheses. But here, if I'm working on both sides of the equation, just do the same thing to each side. It's the equivalent of adding and then subtracting on one side. In other words, what if I brought this positive 81 over to the left? It would have to be negative 81, right? So it would be plus 81, parentheses, minus 81. It'd be the same thing, right? But since we're working on both sides of the equation, just add it to both sides. All right, now this is a perfect square trinomial, which means we can factor this as x minus 9 squared. We know how to do that because we learned how to do it the first time we dealt with completing the square. And that's equal to negative 56 plus 81, which will be 25. Am I right? So now, to finish solving this, we take the square root of both sides, like we did in the previous examples. So x minus 9 equals plus minus 5. And now add 9 to both sides. So x equals 9 plus minus 5. Now, I don't want to leave it like this. I can do 9 plus 5, which is 14, and 9 minus 5, which is 4. So our two solutions here are 14 and 4. Okay, look at number 4. In number 4, there is an issue. We've got this 2. Now, because this is an equation, I can just divide every term by 2. So let's do that. If I divide 2x squared by 2, and negative 16x by 2, and negative 30 by 2, look what happens. The 2's cancel, that leaves x squared, minus 8x, and we'll leave a little space, equals negative 15, and we're going to leave a little space. Alright, so now we're good. Now we're back in the situation where we need to be when it comes to completing the square. So now we're in a good situation here, good shape to solve this by completing the square. We're going to take half of negative 8, which is, square that. Good. So we add 16 to both sides. Okay, now we're going to write the factored form of this perfect square trinomial. That would be x minus 4 squared equals 1. And this is going to work out nicely. Take the square root of both sides. So x minus 4 equals plus minus 1. Add 4 to both sides. X squared equals 4 plus minus 1, which simplifies to 4 plus 1 is 5, and 4 minus 1 is 3. Okay? So far this is working out pretty simple. Now, are they always going to be this simple? No, but the process is going to be this simple. So let's flip the page. Let me make sure that gets on video. Sometimes I don't get it on there. So there it is, guys, if you didn't see it on the video before, if it was not right. All right. Okay, on the back side. Okay, so look at number 5. 4x squared minus 8x equals negative 3. Now, we do not like having this 4 in front of the x squared, so what do we have to do? Yes. Now, that's going to give you a fraction on the right side. That's okay. Just deal with it right now. Just let it go for right now. It's not a big deal. All right, so x squared minus 2x, leave a little space, equals negative 3/4 plus a little space. Notice I put plus because since we're dealing with a situation where when I complete the square, I'm always adding, right? So if I'm adding, that means I don't ever need to put, I'm never going to have a negative right here. So I'm just adding every time. All right? Okay, so half of negative 2 is negative 1, and negative 1 squared is 1. So we're adding 1 to both sides of the equation. All right? So, at this point, x minus 1 squared equals negative 3/4 plus 1. Alright, so what is negative 3/4 plus 1? It's like saying negative 3/4 plus 4/4. So that would be 4 minus 3, which is 1/4. Alright, and again, this is going to work out nicely because 1/4, you can take the square root of that real easily, right? So we're going to take the square root of both sides. X minus 1 equals plus minus 1 over 2. Now add 1 to both sides. X equals 1 plus minus 1/2. Now I don't want to leave it like this because we can simplify this. What is 1 plus 1/2? 1.5. You can write it as a decimal. 1.5. Alright, and then what is 1 minus 1/2? It's a half, so 0.5. If you want to write it as a fraction, it would have been 3 over 2 and 1 over 2. Alright, everything looks good. Okay, let's continue. Yes. Okay. Right here? No, it's right here. It stays whatever this is. So if this is x minus 1, then this stays as x minus 1. Does that make sense? So if this is x minus 1 squared, that's like saying x minus 1 times x minus 1, right? So then when I take the square root of that, I still have x minus 1. Think of the x minus 1 as being x, like x squared. The square root of x squared is x. So the square root of x minus 1 squared is x minus 1. Alright, number 6. Now, this is going to get a little bit more tedious because it's not going to simplify as nicely. Let's go ahead and move this 8 to the other side. That's the first step. Subtract 8 from each side. 3x squared plus 10x equals negative 8. Now, we don't like having this 3 in front. So what do we do with it? We divide it. Now, dividing that out is going to make this a little bit more aggravating because of the fractions that are created. Okay, but you know what? There's no way around it. We just have to do it. So we're going to divide every term by 3. You could have actually done that before you moved the 8, but I like going ahead and getting everything over there on that side. Alright, so now we've got x squared plus 10/3 x plus a blank equals negative 8/3 plus a blank. Okay, this is where it gets ugly. we have to divide 10 over 3 by 2. That's the same as saying 10 over 3 times 1/2. So it's going to be 5 over 2. All right? It comes out to be 10 over 6, and if you reduce that, it comes out to be 5 over 2 or 5 over 3? 5 over 3. Okay, so 5 over 3 squared. Let's first of all put 5 over 3 in the calculator. 5 divided by 3. 5 divided by 3. That is 1.6 repeating. Okay? Now, I can change 5 over... Your calculators will change any decimal to a fraction. Okay? This one, I don't think this one does. It might do it. Yeah, it does it. Alright? Yours does that. But I would prefer to leave things as fractions. So, if I've got 5 over 3 and I have to square that, what does that become? 5 squared is 25, and then 3 squared is 9. So it's 25 over 9. That's what we're adding to both sides. Now, don't let the fractions scare you, because the calculator can simplify fractions. All right? Not that you shouldn't know how to do it, but the calculator will simplify these things. Now, I have done what I needed to do to complete the square. Now I'm going to write the square of my binomial. It's going to be x plus 5/3 equals squared equals. All right, now this is probably not the best format. Y'all remember when we had to deal with the number that was in front of the variable, and we took the second number over the first number and then changed the sign to solve that? That's kind of what this should be, but I'm going to leave it like this for right now. Okay, we're going to leave it just like this. Okay, now, negative 8/3 plus 25/9. Put that in the calculator. Your calculator will do it just fine. Go to second, y equals on yours. Mine's a little different. I'm going to do it in mine. Negative 8/3 plus 25/9. Okay, when you do that, it comes out to be 1/9. This is going to work out nicely. It didn't look like it was going to work out nicely, but it is going to work out nicely. You just have to be disciplined enough to stay with it, to stay with the problem when you're dealing with fractions. It's not a big deal. So now we're going to take the square root of both sides. So we have x plus 5/3 equals plus minus, what's the square root of 1/9? Real easy. 1/3. So now we're going to subtract 5/3 from each side. So x equals negative 5/3 plus minus 1/3. Your calculator will do this, but you shouldn't need a calculator. What's negative 5 plus 1? Negative 4. So our answers are negative 4/3 and what's negative 5 plus 1? Minus 1, sorry. Negative 6 over 3 is negative 2. Negative 6 divided by 3 is negative 2. So, negative 4/3 and negative 2. Alright? The answers looked a lot better than the problem appeared to be. If we converted to decimals, the likelihood would be for you to get approximate answers instead of exact answers. These are exact. These are exactly what they should be. But if I had done 1.7, okay, for 5/3 squared, okay, or actually for 5/3, and then squared 1.7, I would not have gotten, you may have done all the process correctly, you just wouldn't have gotten accurate answers. They would have been less accurate. Alright, let's move on to number 7. Okay, number 7 is a little bit more friendly. Okay, let's go ahead and add 21 to both sides because we need to get the number, the constant, on the opposite side. So x squared plus 16x plus a space equals 16 plus a space. Everybody good with that? Okay, now take half of 16, which is 8 squared is Okay? So 16 plus 64 is? No, close. 80. And then on the left side, x plus 8 squared. So, say what? Okay, that's all right. All right, no problem. It's okay. That's good. All right. All right, square root of both sides, x plus 8 equals plus minus. All right, we need to simplify the root of 80. This is one of those common numbers that we take roots of. You're close. The largest perfect square factor of 80 is
20 and 4.
Nope.
What is this gonna be?
Dun 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 dun. What'd you say? Yes. 16 and 5.
I was just gonna say that.
So 4 root 5. All right. Now, having done that, we're going to subtract 8 from each side. X equals negative 8 plus minus 4 root 5. And there's nothing else we can do. Leave it. All right, I'm going to stop the video, and I want you to do number 8. All right, so because there is a 3 in front of the x squared, we need to divide everything in this equation by 3 to get rid of that. That is whenever we're solving by completing the square, which is what we're doing. So, divide everything by 3. That gives us x squared minus 10x equals 23. All right? All right, so now we need to, I should have left a little space. I'm going to rewrite it. X squared minus 10x plus space equals 23 plus space. Okay, so we're going to add 25 to both sides. All right, so then we are going to now be able to write this as the square of a binomial, so x minus 5 squared. Don't forget that you're going to use the sign of whatever the number in the middle is. So if it's negative 10, you use a negative 5 here, because half of negative 10 is negative 5. Equals 48. Now take the square root of both sides. X minus 5 equals plus minus, and then 16 and 3 are the factors we would use. So this is 4 root 3. Add 5 to both sides. We cannot combine the 5 with the 4 root 3, so we just leave it as 5 plus minus 4 root 3. That is a satisfactory answer as far as I'm concerned. All right, number 9. Now, number 9 is no more difficult than any of these other ones. The only difference is we're going to end up with an I. And that's fine. It just makes it a complex answer. Instead of being irrational, this one is irrational because of the square root of 3. This one's going to be complex because there's going to be an I. So let's do it. So we're going to subtract 43 from each side. So x squared plus 12x minus 43, sorry about that, plus a space equals negative 43 plus a space. Alright, so half of 12 is, 6 squared is, so add 36 to both sides. Now we're going to take the, we're going to factor the x squared plus 12x plus 36. X plus 6 squared equals negative 7. So we're going to take the square root of both sides. So x plus 6 equals plus minus, and it's not 7i. I think I told someone wrong a minute ago. It's root 7i, or I root 7. We can't simplify the root of 7, so it's I root 7. Alright, so now we're going to subtract 6 from each side. So x equals negative 6 plus minus I root 7. Now, I cannot simplify this any further. So we're just going to leave it as negative 6 plus minus I root 7.
So we're going to do number...
Alright, do number 10 on your own. One thing about number 10. Bring the x over and move the 76 to the other side. So you're basically swapping the x term with the 76 and change the signs when you do that.
You think we should do that before we divide?
Do that now. You can divide first. That's fine. Alright, so we're going to, first of all, let's go ahead and swap, well, it really doesn't matter. You can go ahead and divide everything if you want to. Sometimes if you divide first, before you move things where they're supposed to be, you might end up with fractions, and I don't know. So for some reason, students don't like fractions. I wonder why. They just don't. You know why students don't like fractions? Because somewhere down the line, you probably had a teacher that said, I don't like fractions.
No, he didn't tell that. He said,
Okay.
This is how to do it right. It's like, whatever you use,
What? All right.
They didn't say it like that. You know,
All right, so let's go ahead and do this one. All right, so when we do this, go ahead and divide I'm going to go ahead and switch it before I divide. So 4x squared minus 16x equals negative 76. When you swap sides, you change the signs. So we're going to divide everything by 4 now. X squared minus 4x plus a space equals negative 19 plus a space. So it's going to work out pretty nice. Square root of half of negative 4 is negative 2. Negative 2 squared is 4. Okay, so we're going to add 4 to both sides. Now we're going to factor the perfect square trinomial into the square of a binomial. Half of negative 4 is negative 2, so x minus 2 squared equals negative 15. Take the square root of both sides. X minus 2 equals plus minus. Now, can we simplify root of 15? No. But we can simplify the negative 1, which is here. So it's I root 15, and then we add the 2 to both sides. So x equals 2 plus minus I root 15. And that's it. Alright. I'm going to pause the video again. Alright guys, so now we flip the page and we're on the homework page, which is homework 6. It's the last homework page on this packet. Numbers 1 and 2 are like the 2 warm-up problems from the previous page, where we just took these are perfect square trinomials, alright, and you're just going to factor that into the square of a binomial and then solve it. The rest of them you have to start from scratch. So right now what we're going to do are the even problems. We're going to do numbers 1 and 2, both of those. So we're going to do 1, 2, and then 4 through 12 even, and may do some more later, but go ahead and get started on those.